You ever feel like you're talking to two completely different AIs at the same time? I mean, one of them is this absolute genius, and the other one, well, the other one gets stuck on the simplest things. Today, we're going to peek under the hood to see why that happens and what it tells us about how these things actually think.
Okay, let's just dive right into the weirdness. It's this paradox we've all run into, right? You ask a large language model to draft some super complex legal argument, and it spits out something that is shockingly good. But then you throw it a simple little logic puzzle you'd give a fifth grader, and it just faceplants. What is the deal with that? It's a total head scratcher.
And this really is the core contradiction. On one hand, you've got this superhuman performance. These things are mastering skills that take us actual humans years to learn. But on the other hand, they can be so fragile, failing on tiny variations of problems they supposedly understand. It feels like a bug in the system, but some new research suggests it's not a bug at all. It's actually a clue to something much deeper.
Yeah, this whole thing actually has a name, the AI reasoning paradox. And that is the central mystery we are going to try and unravel using a really groundbreaking new paper as our guide. This is where things get really interesting.
So here's the big idea. The main takeaway from the jump. This isn't some error that needs to be patched. It's a fundamental sign that these models are arriving at the right answers using a process that is just worlds away from how our brains do it. They're not thinking badly, they're just thinking differently.
So how in the world do you even start to analyze a completely different way of thinking? Well, you need a new toolkit, a new lens to look through, and that is exactly what this research gives us. A framework, a map, to finally chart out the process of reasoning itself.
You see, the whole goal here is to build a bridge. For decades, you've had cognitive scientists over here studying how humans think and AI researchers way over there building machines that learn in this totally alien way. This paper, it's trying to create a shared language, a Rosetta Stone, so we can finally compare the two, apples to apples. And they use this brilliant analogy to make it all click. Just think about building a Lego spaceship. Yeah, the final model is cool, but the real magic, the real thinking, is in the process, isn't it? It's planning the build, snapping the pieces together, realizing a wing is unstable, and then backtracking to fix it. Reasoning isn't just the final answer. It's that whole messy, creative journey to get there. So the paper breaks this whole building process into 4 key dimensions. First, you've got reasoning invariance. Think of these as the basic rules of physics, like knowing a block can't be in 2 places at once. Then there's the project manager, the metacognitive controls, deciding on the overall strategy. You've got your blueprints, which they call reasoning representations. And finally, you have the actual hands-on work, building, checking, and fixing, the reasoning operations. Okay, let's zoom in on that metacognitive control one, because this one is an absolute game changer. It's that little voice in your head that says, hang on, this isn't working. Let's try something else. In our Lego build, it's that moment you realize your wing design is all wobbly and you have the insight to scrap it and try a totally new idea. It's self-awareness, and it turns out it's critically important. All right, so with this new 4-part framework in hand, the researchers did something pretty incredible. They didn't just sit around and theorize. They went out and collected a mountain of data to see how AIs and humans actually reason out in the wild. And this is where the detective work really begins. 192,709. Just let that number hang in the air for a second. What on earth could that be? That is the number of reasoning traces they analyzed. And a reasoning trace is basically a play-by-play recording of a thought process. They looked at 18 different AI models, from the simple ones to the absolute state-of-the-art, and even compared them against 54 humans to map out exactly how they each tackled different problems. We are talking about a massive amount of data. And what they found is, well, it's just wow. Take a look at this. On the left, where you see all that dark red, that's the strategies AI models use most often. They love stuff like forward chaining, which is basically just taking one logical step after another in a straight line. But now, look at the right. This heat map shows which strategies actually lead to success. It's almost a completely different map. It's night and day. And this all leads to the paper's most jaw-dropping conclusion. And I really want you to hear this sentence. Models are deploying their cognitive tools inversely to what success actually requires. They are, quite literally, doing the opposite of what works.
This misalignment is the absolute heart of the AI reasoning paradox.
When a problem gets complex and messy, the AI just doubles down on a rigid, step-by-step process. But success on those exact same problems requires flexibility, creativity, a diverse toolkit. The AI has all the right Lego pieces, it just insists on using the same simple instructions for every single build, no matter how complicated.
But here's where the story takes a really exciting turn. See, the researchers didn't just diagnose the problem. They actually figured out how to fix it. They found a way to scaffold the AI's thinking process, to guide it toward using its tools way more effectively. And the results were not small. We're talking a 66.7% improvement. That is a massive, massive leap in performance. So what is that number? That's the performance boost they saw on the really hard problems when they simply prompted the AI to use the same reasoning structure that successful humans use. It's a technique called test-time reasoning guidance. It's basically like handing the AI a much, much better set of blueprints before it even starts building. And this shows the difference perfectly. Look at the left. The common AI strategy is to just jump right in, step by step, go, go, go. But the successful, guided strategy on the right, totally different. It starts by taking a breath. It scopes out the problem. It identifies the tricky parts. It plans its attack, all before it ever lays the first brick. So, what does all this mean for the future of AI? I mean, this is so much bigger than just learning how to write a better prompt. This is hinting at a whole new way of thinking about, well, thinking itself. What's more, this research holds up a mirror to the entire AI community. When they crunched the numbers on over 1,500 research papers, they found that more than half of them were focused on that simple, step-by-step thinking. And why? Because it's easy to measure. That crucial, game-changing self-awareness, barely studied. We've been optimizing for the things we can easily count, not necessarily the things that actually matter. And that really brings us to the ultimate and kind of inspiring takeaway. The key to unlocking the next level of artificial intelligence isn't just about more data or bigger models. It's about understanding the process of reasoning. By focusing on the how instead of just the what, we can unleash these incredible abilities that are already lying dormant inside these systems, just waiting for the right guidance. So this all leaves us with a truly profound question. For the first time, it feels like we have a real framework to not just build an AI, but to actually guide how it reasons. So, if we finally have the tools to teach a machine how to think, what are the most important, the most critical, and the most beneficial ways of thinking that we should be teaching it first?